Welcome pre-cal students to class today on Tuesday the 4th. Hope you guys are doing well. Hope you're ready to learn some math today. Some quick announcements. There will be a test this coming Monday. If you cannot make it to my house, please let me know. No later than Sunday, please. No later than Sunday. Your quizzes are due by today. Completely finished, questions asked, and all of that. So please make sure your quizzes are turned in today. And then the reason these sheets are called integrity sheets is you are going to hopefully be men of integrity and be honest. So on Monday, you will tell me how many assignments you have done, how many you have not done, and once you come into my house on Monday, you cannot go back and do any more of these for credit. Okay, so please keep that in mind, and please stay on top of your math. Today will probably be the easiest day we have had all year. But understand something. Understand we will compensate for that with tomorrow's notes and homework. Here's what I'm saying. Because of tomorrow's math being long, I could not combine today's notes with tomorrow. So yes, today is going to be easy, but tomorrow is going to be a lot of work. So enjoy today. That's totally fine. There's nothing wrong with that. Enjoy the short video today. Enjoy the very short homework assignment. But understand, Wednesday and Thursday, we're going to have a lot of notes on Wednesday, no homework, and then no notes on Thursday, but a lot of homework, okay? So be ready for a good amount of work the next couple of days, okay? With that in mind, here we go. Please take some really good notes. We're going to look at a topic today, called even and odd functions. Even and odd functions. The date today, if you'd like to keep track of that, is March 4th, 2014. The lesson number is 1.7. Lesson number is 1.7. We're going to look today at even and odd functions. Now, it would be good if we would start off with two definitions. So please write these two definitions down. What is an odd function? An odd function is a function that is symmetric to the origin. Now, hold on a second. We just learned that yesterday. We know how to test to see if a function is symmetric to the origin. So really, we're learning nothing new today, except that we have another name for a function that is symmetric to the origin, and we call it an odd function. Do you know how I remember that? I remember odd starts with the letter O, and origin starts with the letter O. So if it's an odd function, then that means the function is symmetric to the origin, okay? An even function is a function that is symmetric to the y-axis. So an even function is symmetric to the y-axis. Now, Mr. Art, what about symmetry to the x-axis? Well, think about it. If you have symmetry to the x-axis like this, that's not really a function, is it? Because the vertical line test would fail. It would hit the graph in two places. So anytime you have an equation or a graph that is symmetric to the x-axis, like this graph is right here, that will never be a function because it doesn't pass the vertical line test. So that's why they don't mention here symmetry to the x-axis. So an odd function is a function that's symmetric to the origin. An even function is a function that's symmetric to the y-axis. Man, this is easy. I mean, do you not see how easy this is? Just yesterday we learned how to put functions through tests to see if they have symmetry and what type of symmetry they have. So now we're just going to apply what we learned yesterday, and the math will be very, very easy. The math will be easy. Okay? So here we go. Let's do one example and the video is over. One example. Please copy this into your notes. I want to know, is this function even, odd, or neither? So what I'm really asking is this. Does the function have y-axis symmetry? That's the definition of an even function. Or does the function have origin symmetry? Or neither? So by now we should know what to do. If you want to check for y-axis symmetry, what do you substitute in for x? Negative x. So I'm going to go ahead and put a y for f of x. And everywhere there's an x, I'm going to put a negative x. And then I'm going to simplify. Now this should be pretty easy for you. Negative x to the third power, negative x times negative x times negative x gives you a negative x cubed times a positive 7. That's a negative 7x cubed. A positive times a negative is a negative 4x. and then bring down your -2. I have simplified completely. Did I end up with the exact function I started off with? No, I did not. Not at all. So I do not have y-axis symmetry. Now let's check for origin symmetry, okay? So where the y is, or my f of x, I'm going to put a -y, and everywhere there's an x, I'm going to put a -x. Now, I don't want to be impatient with you students, Matthew, Kayla, but remember, we did just simplify this side a second ago, right? So I'm not going to go through all those steps again. We already know I end up with -7x cubed, -4x, -2. Then bring down your -y. Now, let's go ahead and go through and change all of our signs so that y is by itself. So I'll make that positive. I'll make the 7 positive, I will make the 4 positive, and I will make the -2 positive. Do I have the exact same function or equation that I started off with up here? Well, let's see. 7x cubed is positive, 4x is positive, but look right here. I have a +2 here and a -2 here. So is this function here identical to the one I started off with? No, it is not. So I do not have origin symmetry. So this function is neither even nor odd. That's it, guys. That totally applies what we did yesterday. And now the only thing we've learned new today is 2 different definitions right here. An odd function is a function that's symmetric to the origin, and an even function is a function that is symmetric to the y-axis. That's it. So here's your homework. We only have what? I think it's 8 problems to do. So work on these 8 problems, and we should be pretty much finished. Okay, so call or email if you have any questions. Sorry guys, I had to stop the video there for a second to talk to my son. But anyways, call or email if you have any questions. I hope you guys have a great day today, and I will talk with you tomorrow.